Wind turbines, marvels of engineering, harness the kinetic energy of the wind and convert it into electricity. From small-scale residential units to vast wind farms spanning across landscapes, these structures stand as beacons of renewable energy. But their significance goes far beyond their size. Wind energy offers a sustainable alternative to fossil fuels, without the harmful emissions that contribute to climate change. It's a breath of fresh air for our planet. Yet, as with any solution, there are challenges. Wind energy projects can impact ecosystems and wildlife, but through careful planning and regulation, we can mitigate these effects and pave the way for a brighter tomorrow. Now, as our undergraduate chemical engineering curriculum winds down, we embark on our final experiment, a testament to our dedication to sustainability and innovation. Join us as we harness the power of the wind, not just for today, but for generations to come. Through this experiment, we aim to grasp the fundamentals of different renewable energy sources, focusing specifically on wind energy. By exploring the influence of resistance on energy production, we can learn about the mechanical aspects of wind turbine efficiency. We plan to see how wind speed can impact turbine performance, and we examine how the number of turbine blades can affect energy generation. Our goal is to see how various turbine design choices can optimize performance for wind power generation. We explored the performance of two types of wind turbine blades, a 3-bladed turbine and a 5-bladed turbine. Each turbine was subjected to testing across various speeds and resistances to analyze their efficiency and power output. For each turbine, we conducted experiments at 3 different speeds, corresponding to the settings on the fan that directed wind onto our turbines. Additionally, we tested our turbines under 3 distinct resistance levels, 50 ohms, 60 ohms, and 70 ohms. During each run, we recorded critical data points, including the turbine's angular velocity, the incoming wind speed at the turbine, and the wind speed downstream of the turbine. Our turbines were connected to a Logger Pro data acquisition device, enabling real-time measurement of key parameters. This setup allowed us to capture precise data on voltage, current, and power output at different resistance values. The Logger Pro interface seamlessly interfaced with our computer, facilitating detailed data collection and analysis for each experimental trial. By systematically testing the turbines under varying conditions of speed and resistance, we gathered comprehensive data to evaluate their performance and efficiency. Stay tuned as we delve into the analysis and results of our wind turbine experiments. Data from our experiments point to how an increase in blade number will result in energy output at similar air speeds. This was seen through a lower tip velocity of the turbine blades, as well as lower energy outputs obtained by the power logger. Continuing on this trend, it was found that the 3-bladed turbine had a higher efficiency than the 5-bladed turbine. This efficiency is calculated by using the turbine's power and dividing it by its air power. Power, P, is calculated by using the resistance, R, and the current, I. Available power is the amount of power that a power source can supply to a load under specific conditions. Using our efficiency calculations, we can determine that the 3-bladed system is slightly more optimal under these conditions. This is likely because a 3-bladed system strikes a balance between aerodynamic efficiency and structural stability. Adding more blades increases drag and reduces overall aerodynamic efficiency. In conclusion, we found that a 3-bladed turbine is slightly more efficient under these conditions. A 3-bladed turbine also has other advantages, including lower material costs, noise and aesthetic considerations, and operational stability. A 3-bladed turbine offers advantages under various wind conditions because it is easier to move than a 5-bladed turbine in lower wind speeds. Going forward, more research can be done to optimize energy collection by wind turbines. These marvels of engineering harness the power of wind to generate clean, renewable energy. Wind turbines are a vital part of our sustainable energy future. Together, let's power a greener tomorrow.